Today's lesson is on average rate of change for a function. This is review for you guys. You guys did this last year in Math 1 with linear and exponential. So today we are going to do the same thing. We're just going to explore it with quadratic functions. So last year you did do average rate of change for linear and exponential functions. If you had a linear, remember obviously linear means line. Don't forget. So if you had a linear function, you had an average rate of change and you could calculate it from if you chose these green points or these orange points or really any other set of points on the line. No matter what you did, when you did it, you had a constant rate of change. So everything was the same no matter what 2 points you picked to figure out your rate of change. Then when you did it with exponential functions, that was different because it depended on the interval that you chose. So if we chose one interval, so let's say from x equals 0 to x equals 10, you would get one rate of change, and that was in the orange. And then in the green, if we picked from x equals 2 to x equals 4, it would be different because you don't have a constant rate of change like you do for linear functions. So today's is going to be the same idea. We're just going to be exploring this topic. On page 56, you should take some notes. Page 56 should be blank, just as a review, and pause as needed to take your notes and then continue the video. But your average rate of change, remember, is the measure of how a quantity changes over a specific interval. So we're looking just for how the quantity changes over a specific interval. And then this is what we just talked about. If your rate of change is linear, if you're dealing with a linear function, then you have a constant rate of change. So no matter what interval you choose, you could pick 7 different intervals, and every single time you're going to get the same rate of change if done correctly. For exponential, depending on the interval you choose, it changes. And that's kind of what I was talking about in the last picture. And then parabolic, or for our quadratic functions, it's the same idea as exponential because this also changes depending on the interval that you are chosen. So linear, no matter what, you're always having the same rate of change, but exponential and parabolic, or exponential and quadratic, are going to change depending on what you're asked in one specific problem. Now, this should look pretty familiar to you. To find the rate of change, you use this formula right here. Remember, M represents your rate of change. It's the change in y. Remember, that's what this little triangle means, your change in y, all over your change in x. So mathematically, if you're given coordinate points, it's y2 minus y1 all over x2 minus x1. And remember, it doesn't matter what set of points you start with, but this needs to be the same coordinate point xy, and this needs to be the same coordinate point xy. And then just don't forget that every single time we're finding the change in x, so you're going to be subtracting when you do the formula. So this is the warm-up on page 55. So it says data on a certain car shows that its gas mileage can be modeled by a linear function. The car yields 45 miles per gallon when driven at 40 miles per hour and 25 miles per gallon when driven at 80 miles per hour. Okay, so those are our 2 pieces of information. So it says, what is the rate of change of this car's gas mileage? Well, if we think of speed as our x, our miles per hour, and our gas mileage as our y, then we have 2 data sets. We have at 40 miles per hour right here, then the car is earning 45 miles per gallon. And when you're driving 80 miles per hour, you're only getting 25 miles per gallon. So depending on how fast you're going, that's going to change the gas mileage that you're getting, how many miles per gallon you're earning. So to find our rate of change, it's going to be y2 minus y1 all over, and then since I started with 45 here, remember you have to start with a corresponding x, so 40 minus 80. So you end up with 45 minus 25, which is 20, all over 40 minus 80, which is a negative 40. Well, 20 over negative 40 reduces to negative 1/2. Okay, so what I really want to focus on is what that negative 1/2 means, that you got an average rate of change of negative 1/2. Well, if we're dealing with an average rate of change of negative 1/2, that means, and I'll bring this up here, okay, what that really means is that when you're getting a slope or a rate of change of negative 1/2, that means that the fuel economy is decreased by 1 mile per gallon for each 2 miles per hour, increase in speed. So what this is saying is, logically, the faster you go, the worse gas mileage you get. So if you notice from your points, you could probably guess that when you're going 40 miles per hour, you're getting really good gas mileage, and as you're going 80 miles per hour, you're getting a lot less gas mileage. And if you notice, you have a negative in your rate of change, so that means that's the decreasing part. So we're decreasing by 1 mile per gallon, that's this part, for each 2 mile increase in speed. Okay, so these aren't just numbers. When we're dealing with contextual problems, then you actually have to assign kind of what that means. So it's just not negative 1/2. What does that 1 represent? What does the 2 represent? In this case, it was change in Y over change in X. So it's the change in your gas mileage all over your change in speed. So that's where this sentence comes from. If you are losing 1 mile per gallon, that means your speed is increasing by 2. So you need to make sure you know what is your Y and what is your X, since this is change in Y over change in X. So in this case, it's as the gas mileage changes over how the speed changes. So just to get some practice in today with quadratics, we're going to start doing it just with generalized quadratic functions. So on page 57, you'll see example number 1. And example number 1 says calculate the average rate of change for the function f of x equals x squared plus 6x plus 9 between x equals 1 and x equals 3. Well, the first thing we need to figure out is we have our x's, we have our change in x and change in y, but we want to know what the y is. So if we're going to figure out when x is 3, the function when x is 3 is, we're going to just plug in 3 squared plus 6, plus 6 times 3 plus 9. So we should end up, and you guys be careful when you're doing this in the calculator, especially if there's negatives involved. That's been an issue. So you should end up with 36. So that means we're dealing with the point 336 here. Okay, so then you're going to do the same thing for when x is 1. So the function at a value for x equals 1 is 1 squared plus 6 times 1 plus 9. So when you do that and calculate that, you should end up with 1 plus 6 plus 9 is 16. So you're looking at the point 116. So we're trying to calculate the average rate of change between x equals 1 and x equals 3. Well, now we know we're going to do change in y over change in x. And now we have our corresponding y's. So I'm just going to make this my first point, y1 and x2, y2. So it's y2 minus y1 all over x2 minus x1. And obviously, if you had determined that those points were opposites with x1 and y1 and x2 and y2, that would be fine. You should come up with the same answer no matter what. So you end up with negative 20 divided by negative 2. Negative 20 divided by negative 2 is 10. So your average rate of change between x equals 1 and x equals 3 is 10. Okay. So that's one way to do it. You're given the function, you're given x values, you need to find their corresponding y values and then calculate the average rate of change. Another way to do it is if you look at example number 2, which is on page 58, is graphically. So they don't actually give us what the function is. They just give us the picture of the function or the graph of the function. But they say use the graph to calculate the average rate of change between x equals 3 and x equals 2. So here, when x is, I'm sorry, negative 3. When x is negative 3, we're up at the point 2. And so our point is negative 3, positive 2. And then when we're at negative 2 for x, our y is a negative 1. So I'm going to do this graphically and say, okay, well, it's change in y over change in x. Y, remember, is our vertical axis. So we had a change from here to here. We went from a positive 2 to a negative 1. So that was a change in a difference of 3. And then our change in x, we went from negative 3 to negative 2. So our change in y over change in x in this case is going to be down 3 and over a positive 1. So technically our rate of change is negative 3, but if you remember from our definitions, it says the measure of how a quantity changes over a specific interval. So when we're looking at average rate of change, we're actually looking at absolute value. So the rate of change from x equals 3 to x equals, I'm sorry, x equals negative 3 to x equals negative 2 is going to be 3. Okay, so you calculate it as negative 3, and you want to think of it as absolute value. So our average rate of change is going to be 3 here. So here, why does that really matter? In this case, if you said your rate of change was negative 3, well, we're only looking at one interval. So if you had left it as negative 3, you are technically decreasing your change in y over change in x. You are decreasing on the function. So that negative 3 makes sense. However, when we go to something like example number 3, now we're comparing, and it says for the function g of x equals x minus 3 squared minus 2, so now they have it in vertex form, not that that matters, but just a reminder. Is the average rate of change greater between x equals negative 1 and x equals 0, or x equals 1 and x equals 2? So now this is where you do want to think absolute value. So here, what I'm actually going to do is I'm going to, give me a minute here, I'm going to find my calculator. Okay, so I found my calculator. So what I'm actually going to do, just to save some time, is I am going to go to my y equals, and I'm going to type this into my function. So x minus 3 squared minus 2. And if you look at the window, I always go back to Zoom Standard. Okay, I'm actually going to go to my table, and I'm going to pull my values off my table. So the first rate of change is between x equals negative 1 and x equals 0. Well, at negative 1, we're at the point 14, and at 0, we're at 7. So we have the point negative 1, 14, and we have the point 0, 7. And you could substitute those x's in and get a y. Just for time's sake, I'm going to go to grab them off of my table. And then same thing if you grab the values off of your table for when x is 1 and x is 2, then we're dealing with 1, 2, and 2, negative 1. So 1, 2, and 2, negative 1. So we need to calculate the average rate of change for both of those and see which one is the greater rate of change. So in this case, we have the change in y, so 14 minus 7 all over the change in x. So since I started with 14, I'm going to start with negative 1. So I end up with, I'm going to move this guy over a little more. Let's see, 14, we get 7 all over negative 1, which is negative 7. Okay, and then here, when I do the same thing, my average rate of change is 2 minus a negative 1, so that's going to be a positive, all over 1 minus 2. So I end up with 3 over negative 1, so negative 3. So we have negative rates of change, but what we want to look at, again, going back to our definition, is the fact that this is just how the quantity changes. It doesn't necessarily matter if it's increasing or decreasing. We just want to know how quickly it's changing. So in this case, from x equals -1 to x equals 0, our quantity is changing at a rate of 7. And here, because we're doing absolute value, our quantity is changing at a rate of 3. So if you were to answer this question and say, okay, which one is the greater rate of change? This would be changing at a rate of 7, thinking of it in absolute value. This would be changing at a rate of 3. So I kind of ran out of room here, but the greater rate of change is between our first interval of x equals -1 and x equals 0. Okay. Let's see. There we go. Make that a little bit more obvious. Okay. So the first problem we did, we were given the function only. We had to find our corresponding values. Then we were given the graph, found our values just based on points, and did rise over run, change in y over change in x. This time we kind of did both. We were given the function, but I used my calculator and the table and did a comparison. And then the last way you're going to see it is just a table like this. So they don't necessarily give you a function, and we aren't going to actually find the function on this today. But it says find the average rate of change between x equals 0.75 and x equals -0.25. So this is one point we're focusing on, and this is the other point that we're focusing on. So they give you the x, they give you the y. It's like they've done all the work for you. You just need to use the formula, and the average rate of change here, it's change in y, so 3.44 minus 8.44. all over, since I started with 3.44, I'm going to start with -0.75 minus, sorry, I don't know what's going on. Give me one sec. All right, sorry, problem solved. Let's try that again. So we're at -0.75 minus -0.25. So again, you got to watch your double negatives here. We're going to be adding. So we end up with a change in y of -5 all over a change in y of -0.5. So -5 divided by -0.5 gets me a rate of change of 10. So between x equals -0.75 and x equals -0.25, we've had a rate of change of 10. Okay. So we're going to hold off on that. Your homework tonight is going to be a worksheet, and it's going to review a couple different things that we've been doing over the past couple of days. It's going to have a lot of average rate of change on it, but then we're also going to talk about problems like we did in the warm-up today. And that will be due on Monday. Make sure to check your answers on Google Drive.